So, how did it go? Hope you were able to get this result twice. If not, please let me know and we'll sort out any trouble you're having. But for now, let's move on. Well, what's happening here? Another one that to me screams by parts. Okay, if I have like x times a trig, um, that's by parts is the first thing I think of. Or x times e to the x, or x times ln x. I guess this is something you have to get used to through practice. Anywho, make my choices. I guess I'm following LIPET here. So you have your polynomial being chosen as u. Okay, x to the 1 is a polynomial. Okay, to find du is simple, but to find dv is not so simple. What I'm going to have to do is use a memorized trig identity. Okay, so I've memorized that cotangent squared and cosecant squared are related this way. Let me see. In terms of what you should memorize, I will make that clear at some point soon if I haven't done so already. So I'll give you a list of things that you should memorize. Okay, but this is certainly one, this trig identity. Okay, why did I use that trig identity? Why was I motivated? Okay, I looked at cotangent squared. I looked at it and said, that's not something I know. The integral of this is not something that rings a bell. However, the integral of cosecant squared, that is something that rings a bell, that I have memorized. And I have memorized the connection between cotangent squared and cosecant squared. Okay, so you can see that a lot of this depends on your toolkit. Okay, is your toolkit filled with things you've memorized, or is your toolkit empty? So through memorization, you want to make sure you have all your tools on hand. Okay, moving on. Cosecant squared, the integral is minus cotangent. And then the 1 becomes just minus x, blah, blah, blah. I think the rest is pretty straightforward. Plug things in via your by parts formula. Integral of cotangent is something you will likely just memorize. It's a substitution. You do u is equal to sine to find the integral here. So that's a pretty quick one. So it's up to you whether you want to memorize it or just do it on the spot. I was the kind of student who liked to just avoid memorizing as much as possible, but I'll let you choose what you want to do. So here we go, ln sine x in absolute value. I have two x squared terms, so I need to take a step and combine them. Okay, you'll notice when I grade things that I'm fairly laid back, but collecting like terms is not negotiable. Okay, where are we? I think we're pretty close. So we have to do a combination by parts and definite integral problem. Okay, what do I do? Oh, I'm using my red pen. So you can tell something different's happening here. What have I done? I have an intentional mistake. What is my mistake? Maybe pause and think about what my mistake is here. It is right here. This is not correct. I need this to be, because look, e to the x is downstairs, and then magically it has come upstairs. That is no magic. There is no magic in mathematics. There is, magic. What shall I say? There's no. I don't want to say there's no magic, but no magic of this form, where things go upstairs and downstairs as you please. Oh, where was I? So I need to fix this. How can I fix this? Well, I can just throw in a minus here. It's a negative exponent I put there to fix it. Um, so I want to say again, that's a very common mistake. So please watch out for it. Always check that u times dv does indeed equal what you have here. Because it's unfortunately, a fatal mistake to make. It's hard for me to give you any marks if you make that mistake. Okay, continuing. Straightforward here. Right here, what did I do? If I'm doing the integral of e to the negative x dx, I would do substitution u is equal to negative x. That's probably the easiest way. Okay, so you should do that right now. If you're having trouble seeing why v equals this, I will move on. So I use my by parts formula. And what I'm going to do is put the 0 and the 1 out here. So I'm going to end up eventually with an antiderivative under my red squiggle here. And we'll have the 0 and the 1 outside, and that will be fine. Now, this integral is the same one I had up here, so I won't comment on that. At this stage, you could just plug the 0 and the 1 in the way you usually do. I'm taking an extra step to kind of clean things up a bit. Okay, the negative can come all the way out. And there's a common factor, e to the negative x. Okay, this simplification or this factoring is not necessary, but it does help a little bit when I go and plug in 1 and 0. It's a lot more pleasant when I plug in 1 and 0 to get this rectangle, or to get this square bracket here. Take your pick. A little factoring can help this plugging in bit a whole lot. Okay, work it out, blah, blah, blah. There we are. Okay, where are we now? Is this the end? Oh, it is the end. This is the end. So just one exercise. By parts together with definite integral. Give it a try. Here's the answer, and let me know how it goes.